Good morning, guys.
Good morning, sir.
Yesterday, I was facing some problem with my internet. You must have seen in the news there is some conflict going on. So because of that, they stopped internet, everything.
You are from Haryana,
Yeah, I'm
okay.
quite close to the place where all of this is happening.
Gurugram.
Yeah, I'm from Faridabad, so we are very close.
Okay.
And suddenly everything stopped. Even my phone internet was not working. Then they resumed the Wi-Fi.
Sir, today we can start with problems.
You want to go for this thing, question, numericals, right?
Yeah, numericals.
Okay. Okay, then you can write down uh, the questions. Then we are going to discuss this particular question. Then one by one we are going to go about it. So the first question is a 230-volt DC shunt motor. A 230-volt DC shunt motor, or I'll share the question on the screen so that you can write it fast and you can understand more. Just wait for a second. Can you see the question on your screen now?
Yes. Sir, this formulas we will get in advance for DC motor or when we do problems. Like if in advance it was better, like formulas are organized and can learn that formula and before doing problem.
Then I need to make that particular thing. I don't have anything like that. That all the formula in one place. You're talking about that thing, right?
Yeah, yeah. If with the DC motor, then there will be I don't know how many formulas. So that particular number of formulas like that. Yeah, organized in one place.
That I'll do, but for the today's lecture,
Yeah.
let us start with the problem then. And obviously, there is no point of keeping all the formula in one place. As we are going to progress, obviously, you are going to know all the formulas.
Okay, okay. So we will start now with this.
Yeah.
Okay.
So the question is a 230-volt DC shunt motor run at 1000 RPM. So we know the RPM. So first of all, you should write in the problem what all things you have. So first you have the voltage. So voltage is 230 volt and RPM is 1000. So N is 1000. Let's call it N1. N takes current. You have the current that is 5 amps. The armature resistance of the motor is 0.025. So they are saying armature resistance of the motor is 0.025 and shunt field resistance is 230 ohm. And resistance for the shunt is, so this we say armature resistance is Ra, and for the shunt we'll refer as Rf, just for the so that we can differentiate when we are doing the numerical. 230. Calculate the drop in the speed when the motor is loaded and take the line current IL is 41 amps. So you have to calculate the drop in the speed when motor is loaded and taking the current 41 amp, neglect the armature reaction. So they are saying you can neglect the armature reaction. So now what we have to calculate? Oh, question is also one. You guys already wrote the question or no?
No, sir, no. Sir, could you just show one more time the question?
Okay, just wait for a moment. Better you write the question, because if I'm erasing anything from the whiteboard, everything will go all together. Better you write the problem. Once you're done with the writing the problem, just let me know so that we can proceed.
Okay, sir. Written question.
All of you?
Yes, sir.
Okay. So first of all, we will find out the field current. We have the voltage, we have the resistance, and then we are going to find out the field current. Field current will be equal to IF. First, we'll solve the full problem. Then later on, if you have any doubt, then you can ask me. Okay. IF equal to V upon RF. So from this equation, you can calculate the field current, right? V is 230 volt and field shunt resistance is 230 volt. So what will be field current? What will be the value? 230 divided by 230, right? So write it down. Write down IF equal to VF upon RF. Then if when you are going to solve this one, your field current will be 1 amp. Okay. I can erase this much.
Yes, sir.
Okay, then armature current, we are going to find out the armature current. Armature current is equal to IM minus IF. What is IM? They are saying a DC shunt motor run at 1000 RPM takes 5 amp. So your IM is 5 amp. So when you are going to put in this formula, then you are going to get the armature current 5 minus 1 equal to 4 amp. Okay. Similarly, we are going to calculate this
Sir,
armature
IA
current.
equal to IA equal to what is? IM minus IF.
Yeah,
IM is
armature current.
IA
IM.
IA.
This moment.
Sir, could you just explain the each time IA IF was? It is confusing.
IA is armature current in a DC motor. Okay. IM is motor current in ampere when total current flowing through the motor. So IM is the motor current and IF is the current flowing through the resistor RF. Okay. Clear? Guys, clear or no? IA is the armature current. IM is the motor current, total current. And IF is the current through the resistor RF, right? We calculated IF first, right?
Yes,
Yeah.
sir.
When we calculated IF, that is the current from the resistor, right? We use the formula IF equal to V upon RF, correct? So this is the current from the resistor. We called it field current normally. Guys, clear or no?
Yes, sir.
You are looking in doubt. That is the problem when you directly go for the numericals. So we were having, I hope you all of you have written what is given in the this particular thing. So we know the voltage, that is 230 volt given in the question. Then N1, that is 1000 RPM. Then IM, motor current, equal to 5 amps. RA is 0.025. Resistance, resistance 230. And full load current is 41. Okay. You know all this given in the questions, right? I can erase this one.
Yes, sir.
Okay, then what we need to calculate? They are saying to calculate the drop in speed. We have to calculate the drop in speed. I just ordered the new pen for writing on this screen because this one is not so good. Drop in speed. So for calculating this, we will first calculate the field current. Field current is equal to IF equal to V upon RF. So V is equal to 230 and field resistance is equal to 230. So field current will be 1. Okay. Now we want to calculate the armature current. So for calculating armature current, what we are going to do? We have the formula armature current equal to total current flowing through the motor minus current flowing through the resistance. Okay. So total current is given in the problem, that is 5 amps, and field current we already calculated, that is 1 amp. So armature current will be equal to 4 amp. So what if you want to calculate total motor current, it is equal to armature current plus field current. From this formula, we just bring the IA here and IM here. Sorry, we just brought the IF here, so that IA equal to IM minus IF. Okay. Guys, clear this much or no?
Yes, sir.
So now when you are they are telling the current when your motor is fully loaded. So the current for full load motor is IL is 41 amp, right? Given in the problem. So now if you want to calculate the armature current for the full load motor, it will be 41 minus 1 again, IM minus IF again, right? For the full load. So at full load condition, your armature current will be 40 amps. And there is one formula for calculating back EMF. I think you must be aware of this formula. EB.
Sir, what is IL?
IM, motor current,
IL.
full load
IL.
current, full load current. We just represented by this IL term for the full load current of the motor. Can you see in the problem? Calculate the drop in the speed when motor is loaded and take line current 41 amps. So when your motor is running at full load, the line current is 41 amps. So we are calculating the armature current for this particular motor when it's running at the full load. Clear?
But why we deduct from 41 minus 1? I don't understand. IA equal to
This is the actual formula. IM equal to IA plus IL. For any DC motor, if you want to calculate the total current, it is the current passing through the armature and current passing through the resistance, sorry, IF, through the resistance. This is the actual formula. So you want to calculate IA. So what will be IA as per this formula? IM minus IF, right? As simple as that.
minus IF.
So what is the doubt now?
Sir, IM minus IF, right? Here
Yeah.
IM is 5.
Motor full load,
IF is
motor current, basically motor current. So when you say motor current, we have in the problem, there are two conditions. When your motor is running at no load, it's taking 5 amps, and when your motor is running at full load, it's taking 41 amps. Clear?
sir, we are representing IM equal to 5 already given. Then again IM equal to here. I don't understand the concern.
Let me post the question again. Just wait a moment.
I think in the beginning load is less and
Yeah, there is no load at the beginning.
no load, then 5 amp motor
Yeah.
was
And then there are two conditions. One is at no load and one is at the full load. Not full load, when your motor is loaded. It can take more load than this. So what is they are writing in the question? A DC 230 volt shunt motor runs at 100 RPM and takes 5 amp. So a motor is running at 230 volt, RPM is 1000 and is taking only 5 amp. The armature resistance of the motor is this much and the field resistance of the motor is 230. Calculate the speed. You have to calculate the drop in speed when motor is loaded. So in the first case, when they are saying is taking 5 amp, your motor is not loaded, okay?
Okay.
And takes the line current of 41 amps. So, and when your motor is loaded, instead of 5 amp, is taking 41 amp. So they are saying calculate the drop in the speed. Understood the question now? Understood?
Yes, sir. Yes.
So we are using a formula, and in this formula we are saying IA is equal to IM minus IF. So in the first case, IM will be 5, right? And when it's taking 41 amps in the loaded condition, IM will be 41. Just for representation, one thing we represent by IM, and there will not be any confusion. The other amps we represented by IL. Otherwise, how you are, if you are writing given IM, you writing 5 amp, then again IM you are writing 41 amp. Will you be able to solve problem? So instead of IM, we wrote it as a IL, or you can write it as a IML. Okay. Or you can write current at no load, current at full load. You can write anything. Okay.
Okay, sir.
For elaborating this formula more, so just for your understanding, when a DC motor is running, the motor current IM is equal to the sum of armature current, that is IA, and the field current IF. The armature current IA flow through the armature winding, this flow through the armature winding and generate mechanical torque. This current helping in the generating the mechanical torque, while the field current establish the magnetic field required for the motor operation. You need magnetic field, then only your motor is operating, right? And this current is generating the torque. So if you want to find out total motor current, you have to add armature current plus field current. I hope now it's clear why Im is equal to Ia plus If.
Yes, yes.
All of you, it's clear now why Im equal to Ia plus If.
Yes, sir.
Okay, then we are going to go ahead. So there is another formula now. We are going to calculate the back EMF. How you calculate the back EMF? So there is a formula. EB equal to, you must have seen this formula in your class, maybe 12th. V minus IA plus, sorry, IA into RA. Do you remember this formula for calculating back EMF? Okay, let me explain this formula more. EB is electromotive force, back EMF, V is the voltage, supply voltage, IA is the armature current, right? And RA is the armature resistance. Clear the formula? Why you are calculating the back EMF? It limit the armature current and it control the speed of the motor under different load. So if you want to calculate back formula, electromotive force, EB, then you know the V, right? V is 230, right? You already calculate RA, IA. IA is how much? 4 amps, right? And RA is given in the problem, that is 0.025, right? So when you are going to calculate EB using this formula, your EB will be equal to 229.9 volt. Okay. Clear this much?
In the question they ask, uh, finding back EMF at no load. I mean, at low load, I don't.
In the question, they only asked drop in the speed.
I will drop in this.
They only drop in the speed. They are not asking this. But for getting the drop in the speed, we have to do all those things.
Yeah.
Once the problem will be solved fully, then you are going to get know why we are doing all this.
Okay.
So what is the relationship between EB and N? So your EB is equal to N into phi. This phi is not phase angle. This is magnetic flux. For air, phi is magnetic flux. N is the rotational speed. And EB is the electromotive force. By using this formula, can we write this as EB2 upon EB1 equal to N2 upon N1 phi 2 upon phi 1. Can we write it like that? So phi 2,
Denominator part, no load, no load,
sorry,
EB divided by EL. So what is that EL?
EB2, this is 2. EB2 divided by EB1.
No, this one is load and no load. EB1 and EB2. EB2 is the back EMF when it is loaded. EB1 back EMF when it is no unloaded, right?
Just
Is
a
that?
moment. What you are trying to say?
I'm asking what is EB1?
So
What
how
is?
this EB2 by EB1? What is the is there a formula?
Yeah, I already told the formula, right? And just wait a moment. Let me write this formula again. So the actual formula for calculating, suppose you want to calculate the rotational speed and you have the back EMF, that is EB is equal to N into phi, where phi is the magnetic flux and N is the speed and EB2 is the back EMF. Okay. Now suppose you want to calculate, we can write this formula as EB1 upon EB1 equal to N1 into phi 1. Can we write this formula like this? And EB2 equal to N2 upon phi 2. Can you write like this? So can you divide equation number 2 by equation number 1? What is going to you are going to get? EB2, or you can divide 1 by 2 also. EB1 divided by EB2 equal to N1 divided by N2 equal to, sorry, multiply by phi 1 divide by phi 2, right? I only did that. Guys, are you with me?
Sir, only the terms EB2 means back pressure.
Electromotive force, back
Sorry,
electromotive
yeah,
force.
electromotive force at this 41 that condition, or
Yeah,
uh,
that we are going to put. Just wait for a moment. You understood the formula or no?
the formula I understood only the
Okay.
terms.
Okay, just hold on for a minute. You are going to get to know everything. Don't worry. So we already calculate EB1, right? Using this formula, EB equal to V minus IA into RA, correct? You can calculate EB1 using this one,
Yes, sir.
and EB2 also you can calculate using this formula. What will be EB2? Where voltage will be 230, RA is 40 at full load, right?
Yes.
And armature is 0.025. So by using this formula, we can calculate EB1 also and EB2 also. One is at no load and other one is at load. So by using that particular formula, EB1 will be equal to 229.9 volt and EB2 equal to 229 volt. Okay. This much is clear. Guys, this much is clear.
Yes, sir.
Just one minute, I will calculating EB2.
Just wait. Let me put on the board so that you can understand. So now can you understand EB equal to EB equal to V minus I into RA. So for the first case, EB1 equal to 230 minus IA, you already calculate 4 amps and resistance is given in the formula. So EB1 will be equal to 229 and EB2 will be equal to 230 minus. This is the load at current at the full load. Line current at the full load, that is 40, and RA is already given in the formula. So your EB1 will be equal to 229 and EB2 equal to sorry, EB1 equal to 229.9 and EB1 will be equal to 229. This much is clear now.
Okay. Yeah.
And we have to calculate the drop in the speed, right? So we know this EB equal to N into phi, correct? So by using this formula, we can write it that EB2 upon EB1 equal to N2 upon N1 into 2 upon 5 1. We can write it like that.
Yes.
And we are assuming this particular thing, that magnetic flux in condition 1 is equal to magnetic flux is equal to the condition 2. So magnetic flux 2 is going to cut the magnetic flux 1 in this particular equation. So now we know the EB2, we know the EB1, we know the N1. So can you calculate N2?
Yes.
Can you calculate N2?
Yes.
So, and what will be the drop in speed?
This minus the N2 minus N1.
N1 minus N2.
N1 minus N2.
Now clear? I hope it should be clear now.
Sir, this displaying this is better. Like,
Okay, now I'm using this method.
okay. Thank you.
Now it's okay.
Yes, yes.
All of you clear now? Okay, if you are clear, then we are going to go for the next question. This was the
So do you
question
have the
came.
previous slide that N2? How
Sorry,
do you have the previous slide? How
you
did
want
you
me to
find
go?
out the N2?
How did I find out the N2?
Yeah, yes.
Okay, just
EB1 equal to EB2 and N2.
I think you are more comfortable when they are in the slide form, right?
Yes, sir.
Okay.
So how we are getting this 5-1 and 5-2?
We have what is written in the slide. We are assuming magnetic flux in both the cases are equal. That is the assumption we are making. Otherwise, you cannot calculate. This is the question came in July.
Okay, sir, into fish.
Okay, then we are going to go ahead with the next question. Calculate the EMF generated by a 4-pole wave wound armature when 40 slot and 18 conductor per slot when driven at 1000 RPM. The magnetic flux per pole is 0.15 Weber. You can write down the question, then we are going to go ahead with the solution. You're done with the question?
Yes.
So what we have to calculate in this particular thing? EMF generated. Okay. And what is the formula for generated EMF?
Is generator EMF and back EMF is same?
Yeah.
No. So I think if you could have given a little bit introduction that back EMF and all these things, I think everybody will get easy.
So this is the formula. P equal to, E equal to P into phi into N into Z divided by 60A. So you can write down the meaning for each of the thing. I'll just put on the screen only so that you can. So where E is the electromotive force in voltage, P is the number of pole in the electric machine, pi is the magnetic flux in Weber, N is the rotational speed in the machine, and Z is the number of conductor or coil in the machine. And 60 is constant, and A is, what is the A? Number of parallel path for armature winding. Number of parallel path for the armature winding. You want to write all this or it's okay? Okay, if you are writing when you are finished, just let me know. I think this playing on the board is, I think, more easier in explaining and for your understanding also, right? Rather than writing on the board.
Yes, sir.
Yes, sir.
Okay. Because the first problem took a lot of time and this one we will solve very fast. When you're done with the writing, just let me know.
Finish, sir.
Everybody? Anybody was writing or you're already finished?
Already
Finished.
finished.
Okay. So they are saying the type of winding is wave winding. So for the wave winding, A is equal to 2. Okay. So in the problem, they are telling the number of slot and conductor per slot, right? So you can calculate the total number of conductors. Can you calculate? Number of slot is given in the question and conductor per slot is given. They are saying number of slot is 40 and conductor per slot is 18. So this is no, simple mathematic, right? right? This is simple mathematics, right? Guys, are you with me?
Sir,
Yeah.
could you just tell me what is wave winding?
What is wave winding? Then like this, it will never end, man.
Means for wave winding that is equal to 2.
Yeah.
So means that we have to mug up now.
Okay, wave winding is the type of armature winding where direct current of the electrical machine such as DC generator or DC motor, it is only two primary winding configuration and other being lap winding. So in the wave winding, one coil per pole will be there, double number of commutator segment. Actually, there is no need to go so deep as you are electrical or you are this on appearing for MOE class 2.
Yeah, MA class 2.
Then no need to go so deep. You are just wasting time then. Nobody is going to ask you this even in the orals. And you can mug up this for the written point of view. There is no harm.
Okay.
Because like this, we will be wasting our lot of time. That is a different chapter only. So just you ask just so that I will tell this one what is wave winding. So in wave winding, the conductor are arranged in a specified pattern that create a continuous wave-like path through the winding. So its construction is like that. When they are making this particular motor, it forms a wave-like path. The conductor are connected in such a way that one end of each coil is connected to the commutator segment and the other end is connected to the next coil. So one end is connected to the commutator and other end is connected to the next coil. That is the wave winding. But no need to go so deep as a MOE student, uh, class 2 student, there is no requirement. And you are not going to see all this on board the ship also. Or you want, all of you want to know all this, then from the next lecture, I will find then all of this, then all of these things. But there is actually no need. Okay, can you calculate the number of conductor? They are saying there are 40 slot and per slot is 18. So can you calculate number of conductor or no? Guys,
Yeah, by formula. Yes.
there is no formula. This is a simple mathematic, right?
Number. Yes. Sir.
So your number of conductor will be 720. So we already know the formula. What is the formula? P into 5 into N into G divided by 60A. So now you know everything. P is also given in the formula. Flux per pole is also given in the formula. That is magnetic flux. P is 4. Magnetic flux is 0.015. And N is 1000. G you already calculated, that is 720. 60 is constant and A is 2. So can you calculate EMF? Your EMF is going to be 360. Clear, guys? Guys, clear?
Yes. Sir.
Yes, sir.
Okay. Already we are finishing time for today. What we will do from the next class, I am going to share all these things from the starting only so that we will waste less time. And you are having your exam maybe in the 3rd week of this month, right?
On 18.
On 18 we have the exam. So we have only 1, 2, 3. Hardly we have 2 weeks, right? We have only 14, 15 days from now.
Yes, sir. Also need to one time revise. I mean,
Revise also.
also.
So My suggestion is that no need to go so deep in the formula. No need to go. The more as a marine engineer, the more you are going to do problem solve again and again, the more you are going to learn. Rather than going so deep, then we will not be able to complete the syllabus before your exam. So my primary aim is to cover everything before the exam so that we can do better in the exam. Or I will ask this Dilip sir that we can increase the timing to maybe 2 hours per day, because it otherwise it will be difficult. You are open for 2 hours per day.
Yes, sir. Morning we can do. No problem.
What timing will be sufficient? Or we can do 1 hour in the morning or 1 hour in the evening.
Let's say
No,
we
sir, morning is okay.
1 hour is okay.
Morning, if it is 2 hours, that will be better, sir.
yes, sir.
Okay. Then in the morning, maybe we'll go for 1.5 hours, because
Sir, and also please, sir, give us timing before it's also, because we are waiting from 7
every
o'clock.
day same timing. Every day same timing. If there is no post in the group, the timing is the same as the yesterday's. Okay.
Today also they have sent link after 7:30 only.
Yeah, that also I contacted the admin that please send the link. Then he sent. So if every day is the same timing,
And
in
so
case,
other classes, other institute, they are giving link day before, the one day before itself. Night time they are sending link. So morning we
yeah,
can easily open
just
the
log
link, because we are waiting. We are waiting on Telegram for the link.
yeah, that you can speak with the admin. That is not my job, right?
Yes, sir. Okay. So we have to contact him. No?
Yeah, you can contact admin that we are facing so and so problem, and obviously he should come up with the solution, right? And I will also talk to him, but better you talk this directly to the admin.
Okay, sir.
Okay.
Sir, problems. How many?
If I am not putting, or admin is not writing any timing in the group, our timing is going to be 7:30. Okay. If admin and me are not putting any timing in the group, apart from Sunday is the holiday. You were saying something?
Yeah,
Anybody is saying?
problem. Sir, problems. Like how many years we will practice?
5 months question paper are enough. 5 to
months.
6 months.
Okay.
And you will see, if you're doing 5 to 6 months, already problem will get repeated.
Uh-huh.
Okay. Okay, guys. Thank you for your time. The things you're telling for the improvement right now is for the admin. Please contact admin, and I will also convey your message to the admin. Okay.
Okay, sir.
Okay, guys. Thank you.